Okay, guys, and so the fact that our infrastructure is quite dynamic, that we change a lot of stuff in the background, should not be a concern of our users. It's not only about the users, but it's also about the business. Business does not like if there's some kind of error, they start to doubt in our amazing skills. So it's the very critical ability for our system to be able to hide how much we change in the background, how much we experiment, and how much we are doing with our system. So my name is Wojciech Barczyński. I'm a head of engineer, but my background is software development and system engineering. And my system engineering story started many years ago when I came to the company. And I wanted to build software that make fun doing. But of course, there was a continuous deployment pipeline which was not working. Continuous integration was quite once green, once red. So then I naturally moved to the system engineering. I experimented with Chef, Puppet, Salt, and most of the stuff which is out there. And around 2016, I discovered Kubernetes, and also I become a big fan of Terraform. And this kind of pair helped me to bring startups from a very bad shape to much better shape when developers have a fun developing. And they also have this ability that they can deploy, and in 2 minutes they have it on development. In 2 minutes they have it on staging. In 2 minutes they have production. So no more kind of worrying about how my software is going to reach our customers. And what do we know about development? What do we know about software engineering? Let's take a look what is important and why we at all have this presentation. So first, what we know, we should release often. We should release in small batches. And this is especially crucial in the business, in the startups. We need to let the business evaluate early. So this is always surprising that sometimes it's better to show the business guy half of a feature in development after 3 days of building it and get feedback like, dude, what the hell is that? And I know I just 3 days and not 2 weeks or 3 weeks. And also the fourth point is my favorite. In the word, you need to take and pay back the technical debt. There's no other way. Sometimes you need to reach this deadline, otherwise investor will kill you or clients will leave you. And there's no another weekend. There's no another weekend. There's no another evening. It needs to be done now. So that is why we try to deliver often and small. And there are some kind of bad things about software development. The first, some bugs can be seen only in production, unfortunately. And what is even more surprising, if you build a software for many years, some features can be only verified in production. Because the business guy saw it in staging, but he felt like, it's staging, nothing bad. But when you say like, dude, this is going to production, this is already a production, user don't see it, just flip a flag and user will see it. It's for business people to think totally different and give you some kind of honest feedback. Again, small batch, quick feedback, and we can stop losing time. And also what is important is to understand, from my experience, is that building any software is an ongoing journey. Nobody knows where we're going. And hello? It's always funny when business people believe that developers knows, and developers believe that business knows where we go, which is both not true. So this is another motivation. So we took a look on the quality perspective and business perspective, and here's the story and upgrade. We know that we have customers, so we decide time is Friday, 8 o'clock. 5 minutes to deploy, we're happy, drinking our coffee. And of course, what is going to happen, not a surprise, was an error, 4 o'clock in the morning, and we can enjoy the first light, birds singing. That's a very amazing experience for us developers. And we should avoid this situation as much as possible. That is why we talk today about zero downtime deployments, to deploy often, to avoid this kind of situation that we need to wait for some special time, special moon phase that we can deploy so our developers are not affected. So let's take a look on the Kubernetes and why I use this tool, why it's the tool of choice. I love Kubernetes because it let us to treat the data center as a black box or blue box, you can say. It's just a blue box. It makes infrastructure almost invisible, which for me is amazing. I love it. I'm a software developer. I just want to write code, live in this beautiful, innocent world without enough structure, without load balancers, and without networking. That's the best. So because it hides a lot of complexity, it's quite easy to deploy things like, or develop things like continuous deployment, or any kind of more complex deployment strategies. So, and also, what is the big plus for it? That Kubernetes is cross-platform. So it provides us common language to talk about our application and its deployment in any kind of setup. You like Azure, you like Amazon, Google, doesn't matter. You can use almost the same Kubernetes device. So it's really independent from the application how you have to deploy things. So it's the first time we can have this kind of cross-platform layer with a small star at the end for people who work with Kubernetes longer. Who is working with Kubernetes from you? Okay. Production? Okay. Testing? Did tutorials? Saw the logo? Okay. Okay, so it's a good slide. So first thing for people who didn't work with Kubernetes, Kubernetes orchestrates your application, which is packed in a Docker. So this is our basic package management. Kubernetes can do more of that, but it's for another presentation. It can scale it. You can say like, oh, I have here my beautiful service. I want to have 3 instances of it. Kubernetes is going to scale it for 3 instances and is going to do load balancing. For people who enjoy configuring load balancer on Amazon, on Azure, they know how much in the S it is, and here we have it for free. We don't need to orchestrate anything. So if one of your nodes is going to burn, this is going to restart your application on another node. And we have service discovery, which make it very easy to push many integration decisions to the runtime. We deploy something, and magically, for example, our application can talk with monitoring solution, logging solution, maybe security checks. And some people call it even application server or new Linux because of that, because of this kind of simple language that we can compare to other things we tried so far. For example, OpenStack, which was not a language. Kubernetes seems to be much simpler, and that's why people call it even new Linux. And that was also a goal of the creators of Kubernetes. To sum up, here, a happy developer writing his code, pushing an application in a Docker, and then saying to the Kubernetes, here's my beautiful application, please run it. And Kubernetes is going to run it. And let's take a look how Kubernetes works from the user perspective. So first things, what is happening, user is using some kind of URL to get to our system. And the first component that our user is going to experience is ingress controller, which will make translation between these URLs to our internal components. So this is the first layer where we can hide complexity. How will it look without this animal? We can say, okay, dude, if the user hit, or our mobile application hits this URL, it's going to be redirected to the service users minus version. People experienced with Kubernetes can notice that I will make simplification, but this is for making it more clear. Version 1, we can say that there's service version 1, and let's imagine we made a lot of mess in version 1. We don't even want to open it. We wrote it in the PHP with bash. We don't want to even open it. But what we can do, we can hide this implementation data from the user and have another service version 2, written, for example, in such a sexy language like Golang. And then we can redirect a new request to a new service. And of course, there's a lot of complexity to the database layer, but today we are talking only about easy things, so I'm not going to talk about database. And here is another example. This is our sibling company, and we also host the website. So there is a service website. How does it look like? This is how the service look like. So we have a service, and service is a virtual address or DNS entry. By DNS entries, I mean users version number 1 will be injected in all the applications running Kubernetes. And then you can just simply access it. So you don't need to think about it where it is. How many instances? 100. You don't even know whether the service is inside Kubernetes or outside Kubernetes. So it's hide a lot of complexity. And it works like that the service look only on labels. So it's another decoupling. For example, here, what we can see, here's an example. Here's the service website, and it says, I'm going to redirect all the requests to me on port number 80 to all the ports with the label app, website minus SMAC value. It doesn't care where it is. And here is also, as you see, because of this decoupling, here we can also make some magic, which I'm going to show you later, that we can hide the fact what actually the implementation is. After that, of course, we have our application. So here I show you that there is a pod. In pod, we have one or more Dockers, usually one. And these Dockers, these pods contains the Dockers. And these Dockers actually are implementing the service. Kubernetes have this extra abstraction, which is called pods, but this we can, because they assume that you can have more Dockers inside the pod, inside the pod, and the deployment define how they look like. Here's the definition, and I just want to show you one thing, which is important for our presentation later, that we can say, okay, this deployment is going to generate pods with these labels. So independently deploy our implementation and the service definition. If we take a look on the summary, we have a service, which is interface, entry point, deployment. We can think about it as a factory if you're a Java or C# developer. And the pod is the implementation, actually Meet, that's going to implement and realize the service. I think that was the basic concepts we need for the rest of the presentation. And my presentation now going to consist of two parts. It's going to be the presentation. We have going demos. I prepared for you, just going to check it to make you more excited about it. I have for you 5 demos, which shows how to implement different stages. So after the presentation, you can go back home and play around with this yourself. Okay, so we are going to talk about replace, which is the downtime. We are going to show how to replace all our old application with new application. We're going to take a look on the rolling updates, which is the most popular, I believe. Blue green, especially Netflix like this kind of deployments because they can always fall back to the old implementation, and Canary. And the one which I'm not going to show you and not cover in the demo is shadow deployment, but I'm going to tell you what is it, syntactic canary and feature toggles, also well known as A/B testing, which can be also done on infrastructure level. But before we talk about that, first we need to prepare our service. Our service Kubernetes regarding the state with Kubernetes using 2 probes. One is liveness, we're saying if I'm alive or dead. Whenever you are going to return on this probe something, Kubernetes is going to kill you in 30 seconds. If you return something else than 200 on readiness, Kubernetes knows that you are not ready to serve a traffic. And especially this one is very useful because we can, for example, prepare ourselves to shut down, as I'm going to show you in a second. And of course, another homework, which is a tedious topic, is monitoring. Of course, I assume that you have monitoring, because without monitoring, any kind of deployment strategies are not very useful, because you don't know whether you are dead or not, but you don't know whether your customers are going to call you in 10 minutes and complain, or worse, your boss or an investor. So here's an example of liveness probe. So we say here that I have a path which is /model on my application. It's on port number 8000, and please ping me. Ping me every 5 seconds. And ping me first time after 1 minute. This is, for example from our big machine learning-based component, which needs around 1 minute to load all the data. Otherwise than that, it's very fast in production, but we need to pay it with deployment time. And here we can also set up the threshold. So anytime this is going to return something else than 200, your pod is going to be dead. And Kubernetes is going to try to restart it as long as possible. And if you're going to crash 10 times, depending on configuration, then you are going to get to such a state like crash loop, and Kubernetes is going to stop doing anything. Here's another example, but for readiness probe. Here I choose a little bit different example to show you that the readiness probes, they don't need to be necessary HTTP requests. This is especially useful if we have some kind of old style application that still use files to communicate its state. We can also run a command on the bash. And this command is going to be run every 5 seconds and after 5-second delay. Because of course some components need a little bit more time to get up. And we need to respect that. And what is going to happen now if we have these two probes? So first thing what we needed to do, implement readiness probe. And we need to handle properly a signal from Kubernetes that we are going to be shut down. Because we need to finish what we are doing. Otherwise, users will see that we are going down. So first thing what is happening as application, we get a sick-time signal from Kubernetes. And what we need to do, we need to send on readiness probe something else than 200. Otherwise, we'll get new requests, which are or finish in the middle. So this is very important. If you develop it, then you need to give 500 or anything else. 400 is also good. Somebody has his favorite or her favorite HTTP code, she or he can use it here, but not 200. And Kubernetes stopped to send requests. The new requests are going to get to the new component. And the last thing, what we need to do, we need to shut down gracefully. If you are not good component, Kubernetes is going to kill us. After 30 seconds per default, and we can extend it to 60 or even more seconds. But usually, we should not reach this level. If we reach this level, it means that we are doing something not good, and it means that we don't really understand our application, because we should not get there. And here is, this is, of course, why readiness probe is important. And regarding the implementation, I just want to show you one implementation from Golang. In the GitHub repository, you can also find implementation for .NET Core, .NET Core 2, I don't know how they call it, but it's C# for me. C# something. And here you can find out how properly handle the shutdown, how to return properly output on readiness probe, how to close cleanly, finishing for the ongoing requests. Here's the Golang code. I simplify it. You can take a look on the implementation of the library. It's open source. What I want to show you is that we have one function which set up where we wait for signal. And when we get that signal, it's here. We are waiting for the signal here. We are going to set up the status not ready, and then we shut down. It's very simplified, but you can click on the code, take a look how it's implemented in Datas. The most important thing is got a signal, set up the probe. That's the key of your preparation, apart, of course, of monitoring. So let's take a look on the short demo, because I want you to have some fun at home. So here is the application I was talking about. So here I'm going to create the pods. Here I started 2 pods, 0 demo 1 and 0. Take a look here. I'm still returning I'm not ready because I configure it like that it waits for me a long time. And now I'm ready. I'm going to serve the traffic now. And here here we can see the changes. I don't know what you see in the background, but the key is we can see that we are hitting both services, one, another. And for you just to play around with that, yep. Okay, so here you can see that we hit both of them. It is like a toy example, but I think it's very good for understanding the overall concept. At least it was for me. So what I want to show you is, oh, come on. Okay. First, what we can do, it's a simple application. I can, by REST API, I can say what should be a status on the probes. So I can say like, oh, please set up the probe readiness to not ready. And I can execute it. And what you can see is because of the configuration, it will try several times, because it's for the demo. So I wanted that you will see this time passing by. And instantly, you can see that we have not ready, and here we should have 0. And now, we switched only to one instance. So Kubernetes does not forward the request to the dead instance. Of course, if we get healthy again, then what we will see after a few seconds, we get them back. So we are using both instances. And the last thing, in case you don't believe me that your component is going to be killed, we can set up ourselves unhealthy. And there's also a configuration we find out. It's very pragmatic, so it waits like 5-6 seconds in order that we can see what we see. Okay, and we got killed, and the instance is going to get restarted. That was the first demo. And you can do exactly the same for the C# component. Okay, so the next strategy that I'm going to show you is recreate, the same way I did before. So we have version 1, we want to move to version 2. And the integration option that we are interested in is recreate. We can set in deployment file that we want to have recreate deployment strategy. So all the old are going to get killed, a new one created. And here's the command. This is a command I use to switch from the version 1 to version 2. And this one is very good for deployment environment or staging environment when we want to go really fast. So we just want to delete everything and get new ones. And what you can find it also in our demo. So I can do it, apply. The same as before. You have curl, we have nodes, and we can do the set, changing the version of image one to another. In Kubernetes, we can do it in many ways. We can do it like that, how I did it. You can also configure it in the deployment file and then apply all configuration files. So this is what I wanted to show you, is deploy from the scratch. And then because of the flags, waiting flags, it wastes a lot of time, like 5 seconds before it's ready to serve, and you see that we have 2.0. So of course, it's like a baseline, we just recreate everything. Okay, let's get rid of this one. The most popular strategy is updates. So what we are going to do, we are going to replace one after. And here, what do we expect from Kubernetes? We should not see any downtime. And this is what we are going to show. See, and the configuration options which are interesting for us is first, we need to say rolling strategy for the Kubernetes, and we also need to specify how many new instances have to be created before tearing down the old ones. So it's a max search. It's very important if you have not too much resources, so I would not go too aggressive here. And here you have the documentation. And let's say works. Very similar like last time. Apply. Curl. Oh, something is dead. Okay, oof, works. So here is our version 1, and what we are expecting to see is rolling updates. The same way as we did before, the same command. And here what you can see this max search. So we get 2 instances. Kubernetes waiting till they are ready. When they are ready, it's going to tier ones. And ones also should be properly, so they should set up the readiness probe. I'm not ready, and we should not see any kind of change. And here you see that we have now one, still one instance of one, and later we have just two. And this process will stop if the new instance is not going to get up. You can configure it like that the whole rolling updates will stop if the new instance is going to crash or is not going to be ready. So it's some kind of support for us if we want to stop the process and we made some stupid mistakes like wrong configuration file. And here what we expected to get like version 2.0. And here you can take a look on yourself. It's more like educational presentation tutorial than talk. Here you can see the implementation of liveness probes in every of these scenarios. Also initial delay seconds, that is why we see so late zero readiness, because it waits, and then how much we are going to probe it. And these Dockers are in the Docker, so you can just run it on your laptop in 5 seconds. Okay, that. Rolling updates, I think is the most popular. In my company, we're using mostly this. Another one is very popular is the blue green. And here what we can do, the idea is that we have a blue deployment, this is our old version, and then we prepare everything for the new version, this is our green. And what we want to do, we want to switch between them. In this strategy, what is nice is, and this is quite popular in Netflix and big companies, that the blue still exists, it's not touched. Usually it's completely independent from each other. And then if something goes really bad, you can go back, which is quite nice feature. And if we take a look on the implementation which I provided to you, is here I'm doing like that I changing the service implementation, the label. So here is the service implementation. We have API and we have a label, blue. Exactly the same label we are going to have in the old deployment. In the new deployment, we are going to have a green. And we are going to use the Kubernetes API to patch and change the label from blue to green. And we can immediately switch from the left to right. So we have blue and green for us. And then what we want to do, we want to patch it. So we have blue, and we want to make it green. And this technique we could use also on an ingress level. And here what we see is immediately we switch between them. Maybe not rocket science, nothing blow up, no fireworks. But I think in compared to other technologies, it's quite amazing how simple it is. And then I can demo them all in front of you so easily. Another quite interesting technique is, of course, this is the example of the command I was using. And this one is for big changes. I use it much less, but I'm still working in a startup which doesn't have like 100,000 of clients. So I don't use it so often and might be implemented in ingress. And also make the switch on the ingress level. And usually I think this one is probably more secure because then you can specify a new URL for a new version. But if you are stuck with the old version of your mobile phone, sometimes you don't have the option to change the URL, which is hard-coded in a mobile application. And the canary. The history of canary is like, the idea of canary is that we are going to move gradually traffic from the left-hand side to the right-hand side, and wherever everything is okay, then we move forward. If there's any mistake, we go back. And then usually it's happen, if everything is okay, then the environment switch the places. This one is production, and this one is new canary. And this kind of deployment led us to test or see bugs quite early. And usually what we can also do, we can also restrict users who see the canary. Sometimes, for example, what happens when Facebook is testing its application, it's, for example, exclude all IPs of all journalists and big media. Yes, so if you are a journalist sitting in the office, for sure you are not going to see any kind of testing canary or any kind of shadow feature that they are going to test on people around the globe. Most probably it will be some small village in Poland or USA. So to have always this wow effect. So we can do it in two cases. One, you find the Git repository, it's manually, so you can easily do it yourself. So it was like that, you decrease one and increase another one. But you can also make it more smart. So you, for example, you can use Traefik and ingress controller for changing the percentage. For example, you can say 99% should be in my old version and 1% in the canary, and change these probabilities step by step. And if you take a look on the implementation, how it's done, it's also work out the box, is we are working on this file exactly. First 100% of version 1, and then gradually, if I would show you the demo, this would be as expected. I would change it 50 and 50, then you would see one green, one blue, one green, one blue, one green, one blue, and then in the end we would switch to this kind of moment. Then we have something on the version number 2. Oh my God, I'm running out of battery. Okay. Okay, so you could also do it with Istio without any issue. Quite similar, it was quite similar. Or you can also do it in with Traefik or any kind of other ingress controller like Nginx or build it Traefik control, ingress controller. Another technology, not going to demo it, but it will appear probably in my Git repository in 2 weeks, most. It's shadow deployment. So what we are doing, you are replicating the Traefik. This is especially useful for new features. We use it a lot if we have a use case that we want to rewrite some microservice. And sometimes what happens, we are rewriting and we're finding ourselves in the situation, we think like, oh, maybe old one was good, so let's throw away the new one. And this gives us possibility to test even in the production when the business guy gets some kind of hidden URL and can see how it's going to work on the production data. It's very powerful, especially for this kind of small shadow deployment, when you shadow deploy a component. Because we are not Google or big company, we don't shadow so much. Usually what we do component-wise, and it's especially useful for getting very direct and fast feedback from the business. And if you work a little bit longer in our industry, you know, we're wasting a lot of work because we didn't understand properly or we didn't properly talk feature with business of the user. Usually it's the discovery. So we need to push this discovery point as early as possible. And shadow deployments let us to do it. Facebook is famous for shadow deployment. They say in the find all the features which are to be released in 1 year, like from now to 1 year. That's why the application is 200 megabytes or something. So this is what I say. And the shadow deployment, of course, is much easier to implement even on lower level. If you have Kafka, RabbitMQ, it's quite easy to deploy it and install it. Another one which is much more advanced, I have never done it, Twitter does it, that they can even compare the shadow deployment and the current production, not only on the metrics level, but also on the exception level, on KPI level. Based on that, and create and make a decision whether they go production. I have never done it. It's like cosmic technology. Maybe one day I will do it. Syntactic canary, this is more for smaller companies. What we do, we prepare a request which look like a request of our users, generate a lot, like some kind of subset of them, and we run them all the time on production and canary. Some kind of like, you can think about it like kind of extended end-to-end acceptance tests, which also give you this kind of feeling that if it works on production, it should work on canary. We also use this technique in my company. And the last one, popular is the feature toggles. We deploy something, we don't show it to the users, and then we can have a switch. Here you can find extensive blogs, but maybe it would be for another talk, versatile for another talk. One thing which I want to just to say, it looks so easy, it is quite easy to implement. There's one caveat, all the intelligence, all the complexity go to the application. I don't need to say that we need to take care of the application, we need to take care of the database. The schema has to support the old version, and the new version you have to window of the versions. You need to do it in every fragment of your system, so you can always come back, for example. Or, for example, you don't mess up your future deployments or old deployments. So there's a lot of work and a lot of fun as well. So coordination, metrics, Here I also put 12-factor apps because this also gives us some kind of directions where we can go. Just to sum up, for sure Kubernetes it makes it much more easier than with our previous technologies. I used to work with Amazon, I used to work with startups, I used to work with Puppet, what you name it. Probably I had my hands on it, but it's first time we have so simple language to talk about deployments. It's not a silver bullet. I would not say it's like amazing silver bullet, but it's the closest thing so far we get it. Why it's so popular? Because you can always think about it is something like distributed init script. And we try to make distributed init script since 90s, and we're not very successful in it. So if you can think about, if you are like wondering why it's so successful, is because of that. For even this basic functionality, people go for Kubernetes. As I said, application and storage must be smarter. And of course, keep changes small. And if you want to learn more about Kubernetes Cloud Native, there's a conference this year, and you can also meet me in the Golang meetup. So if you want to learn more about building application for Cloud Native world. So if you want to ask me regarding Kubernetes, you can approach me by email or after the talk. And I think that would be all from me. Just want to say you that you can find it on GitHub. My purpose of this talk is for you to use it. That's why I prepared so much demos, because I also learn a lot. And I think there's not so many like out-of-the-box working demos out there, like simple to start. That's why I also prepared this talk and this presentation. And of course, as everybody, we're hiring. And let me know if I can help you with Kubernetes now, later. If you have any feedback, just let me know. Thank you.